Hello and welcome to our presentation about construction workers' situational awareness and overlook perspective. We, Seppänen, Peltokorpi, Lavikka, and myself, Christopher Görsch, are delighted to get the possibility to present our work here at IGLC this year. The research objective of this paper is to work out the current on-site situation of workers and their role in production planning and control. This has been done through a literature review, which should contribute to identify gaps in recent lean construction literature, focusing on situational awareness support for on-site decision-making to boost productivity, and the involvement and the contribution of workers for planning and control. These gaps led to a proposed research method which attempts to classify and document tacit process knowledge of construction workers to capture situational awareness. And we hope the proposed method and its execution can open an avenue for further research. So in a knowledge-based industry, like the construction industry, the skills and experiences of people are the keys to competitiveness, which relies overall on the ability to create, organize, transfer, and leverage knowledge. But the construction industry is struggling to provide enablers of knowledge sharing to increase labor productivity. Reasons for this inability, among others, are construction projects are basically developed while buildings are being created. So here, team members come and go, which leads to a fragmentation of knowledge. Especially in a sector where trade partners are hired for specific and specialized jobs, applied knowledge and expertise become the competitive advantage of their business. So knowledge is power. Here, the individual task completion becomes more critical than the overall project success. But unfortunately, craftsman knowledge and expertise and their ongoing project information are insufficiently integrated because information usually flow unidirectional, what means from management to worker level, so top-down based, and not vice versa, bottom-up wise. In production planning and control, there are possibilities to integrate on-site and decentralized knowledge over time to handle upstream variability by keeping plans and designs up to date and aligned with the project progress. This possibility is provided by the last planner system and is basically a social process which builds relationships and strives to use commitment. LPS approaches can be seen as a method to increase knowledge sharing and to capture an on-site situation picture. The more knowledge and real-time data is integrated, the better the technical production system is updated, which is stabilizing and improving the workflow by an increased situational awareness, which leads to profound decision-making and ultimately to an increased productivity. So striving for this means integrating all information sources and players on site, but several studies have indicated the involvement of the workers level in the last planner system is understated. As shown, the utilization of workers' knowledge can be highly valuable, but it's often neglected. It seems the contribution workers could make to production planning and control is overlooked. So how does the current understanding of the workers' role look like? By limiting access of workers to production planning and control, plenty of knowledge stays unused in human memories. Those best practices and tacit knowledge move insufficiently utilized from one project to another. With this in mind, craftsmen can only be seen as an information receiver and task executor, but not as an information sender, task definer, on-site investigator, and/or task controller. A conclusion of this can be the current understanding of the worker's role does not fit or only partially to transfer and sustain competitive advantage and to create on-site situational awareness in a knowledge-based industry where people are the keys to project success. The perspective of workers role leads to an on-site situation of workers, which highly depends on players upfront in the value chain. Hereby, the quality of documents, like designs and schedules, are often poor and not providing enough information for workers. This would call for critical reviews of designs and plans through decision makers with on-site knowledge. But general contractors lack in supporting trade contractors, which leads to a situation where they are left alone with the responsibility to manage and coordinate tasks by themselves, disciplinary and interdisciplinary. So trade contractors often start also constructing a few days after signing the contract. Such a kickstart leads additionally to little possibilities to influence designs and schedules, where ad hoc decision making and improvisation becomes a daily routine. So overall, this shows a situation which indicates a lack of situational awareness of workers. But we are assuming construction workers have a very good understanding of an efficient production process execution and needed preconditions to do so. That's why we concluded it's worth to investigate their situational awareness to capture tacit knowledge further. This slide shows the first steps of a proposed method to measure situational awareness and capture this tacit knowledge of workers. So in the first step, therefore, we developed a survey which hopes for about 1,000 participants. This survey will be a quantitative investigation of the workers' understanding of on-site processes to develop a more systematic understanding and sharpen the focus for the next steps of the method. And as a next step, we are planning to track workers via helmet cameras. So this data collection will contribute to get the visualized workflow of a specific task of a worker. This can become an issue of ethical concerns, why careful managerial considerations are needed to communicate and mitigate the negative effects of vision-based monitoring. Here, workers need to be informed about the monitoring process, its purpose, and usage of captured data upfront. And furthermore, the study will take approaches that anonymize identities into consideration. On the next slide, or on our last slide, you can see the third step of the proposed method, which is called best case scenario. Here, the tracked worker from step 2 will get the task to describe an optimal execution of a given assignment. This assignment will be the scenario from the video. And then the worker shall describe which preconditions are needed and how his individual execution procedure would look like to deliver the task most productive and with minimal waste occurrence from his point of view. The purpose of this step is to capture the understanding of construction workers' information needs for efficient task delivery. And from this point on, we have two data sets, the video tracking data and the best case scenario data, which can be compared with each other. And through structured interviews in form of a goal-directed task analysis, GDTA, situational awareness can be measured. And in the interviews, chosen video material from the helmet cameras will be reviewed with the same worker to investigate reasons for possible improvisations related to preconditions and deviations from plans and designs in comparison with the described best case scenario. So overall, this shows how to capture situational awareness of construction workers to provide more sound preconditions of a task and to improve the disciplinary and interdisciplinary coordination of individuals and crews as well as their overall decision making. And finally, we think this can be a contribution to move from an individual point of view, so resource efficient based, to a more global understanding of the project status and progress, so flow efficiency based. Thanks for your attention, and I'm looking forward to your questions.